Hello everyone, have a very good day. My name is Ana Acosta. I am an industrial engineering student in the 7th semester. Today, I will be talking a little about welding and more specifically about tungsten inert cast welding. Ready? Let's go.
Welding is a process in which the union of two or more pieces of material, generally metals or thermoplastic, is carried out, usually achieved through coalescence fusion, in which the pieces are welded by melting. There you can add a filler material of metal or plastic which when melted forms a pool of molten material between the parts to be welded. The welded pool, and when cooled becomes a fixed joint to the which its the denomination core. Sometimes pressure and head are used together or just pressure itself to produce the welded. This in contrast to soldering and brazing, which enable mating allow melting.
The Middle Age brought advanced forged welding, with which blacksmiths repeatedly strode and had the metal until bonding occurred. In 1540, Bonocio Vernozio publishes the Pyrotechnia, which introduces descriptions of the forging operation. Renaissance artisans were skilled in the process, and this industry continued to develop over the following centuries. However, welding was transformed during the 19th century. In 1800, Sir Humphrey Davy discovered the electric arc, and advances in arc welding continued with the inventions of metal electrodes by the Russian Nikolai Slavnik and the American Coffin in the late 1000s.
By fusion, electric arc, laser, electron beam, thermal aluminum, and oxyacetylene, which vary in electroquated submerged arc, open arc, MIG, TIG, atomic hydrogen, and plasma. By pressure, it can be cooled with ultrasound, indentation, and explosion. It can also be by pressure, continuous resistance, projection, and stop point. Arc welding with an infusible electrode and inner cast protection is commonly called tungsten inner cast. It is an autogenous process in which the heat is produced by an arc that coils between the workpiece and an infusible electrode that is thus not is consumed. The electrode is made on tungsten or tungsten alloys. This material have a very high melting temperature with the thermonic emission properties that facilitate the operation of the electric arc.
TIG welding metals the edge of the workpiece. Stick filler material is used to create the joints. During welding, the torch discharges inert gas. The gas flow protects the electrode, the weld pool, the arc, the filling material, and adjacent areas of the part from air pooling. TIG welding is suitable for all types of carbon steel. Low alloy steel, stainless alloys, nickel alloys, aluminum and its alloys, copper and its alloys, titanium, magnesium, and other non-ferrous alloys. This use of an invasive electrode makes the EG welding especially suitable for metals a few millimeters thick. Because the electrode is not consumed, welding can be done without filler material. Welders enjoy good bad control welding because visibility is not impeded and no metal suitable for all transfer occurs in the arc. The process is suitable for all forms of work and can also be carried out on same lamination of a few tens of tickets. The intense and constant intense heat source of the EJ welding allows discrete welding speeds to melt the edge of the workpiece without excessive risk of penetration. Current modulation allows welders to adjust the process to meet special requirements, used to create high quality acoustic when working with sensitive material that cannot tolerate the high temperatures needed to create a weld. The great advantage of this process is basically the obtaining of cords that are more resistant, more ductile, and less sensitive to corrosion than in the rest of the procedure, since the protective cap prevents the contact between the oxygen in the atmosphere and the fusion bath.